Okay, here we go. Getting set here for day 6 with Algebra 1-2. We're going to do factoring special cases today. This is going to be, honestly, one of the fastest ones that we do. So I think you guys are going to like this. Oftentimes students, the main thing for them is to figure out that we need to recognize what happens here and that it's a perfect square. So you may want to always use your calculator, know where the square root button is to test this second term of the binomial. All right. So in the past, what we've been doing when we had a trinomial, obviously this is not, but I'm just going to compare this to something. This would be like having x squared plus 0x minus 9. Whereas in the past, we would have multiplied a would be 1, a times c is negative 9. And so we would look for factors of negative 9 that combine to 0. So you got 1 and 9 or 3 and 3. So if it combines to 0, these two, we can make it a negative 3 and a positive 3. And so our answer ends up x minus 3 times x plus 3. Now, do you have to write all this out every time? No, you do not. Absolutely not. So you can save yourself a ton of time by recognizing this only works when it is a binomial, okay? Meaning you got two terms, so that's why I've already got these ready to go. So we can skip all of this as long as we know that this is a perfect square. Now this is what we call a difference of squares. And it only works whenever you have a subtraction sign here. So notice on number 2, I've got parts A, B, and C. They are all only subtraction. Okay, if any of these were to be a plus sign, it would not work. Okay, guys, mainly because the reason that happens is if I were to double distribute this one and this one, we end up with plus 3x and minus 3x. And what happens is those just cancel out. Then you'd have the x squared and the minus 9. That's where the x squared and the minus 9 comes from that. So that's working backwards. But this is what ends up being our answer. Okay? So now moving on to this one, we can go quite a bit faster. So now we know we need 2 parentheses boxes. We are always going to have one of each sign because we need whatever the square root of that is to cancel out like it did over here. So we've got a and a. We're going to have plus and minus. And the square root of 25 is 5. And there we go. That's it. That's all you got to do. Like I said, students often like this one because there's not a whole lot of work to show. You get straight to the point, straight to the answer. Does it matter if you put minus and plus, whichever one's first? It doesn't matter. As long as you have one of each, like I said, they can be switched around. All good there. Okay? So this one, we got b squared this time minus 64. So the square root of b squared is b. We got to have a minus and a plus, so it doesn't matter. So I'm going to mix these up. It doesn't always have to. Some students always want to put plus and then minus, or vice versa. It's okay, either way. Square root of 64 is 8. So there we go. That's it. That's all we got to do there. B plus 8, B minus 8, in either order. Okay. Last one, 100. Now, if this were 99, we couldn't do anything else with it. But because it's 100, 100 is a perfect square, 99 is not, we can go C plus 10, C minus 10, right? And then that, again, that's it. So these special cases go really fast. And hopefully, if you need to, pause that screen at any point. Like I said, once you get the hang of these, I think I mentioned on one of the last videos, is as soon as I have one up here, if you want to pause it, try it on your paper, and then check your work and see if you got it right. That's a fantastic way to practice here. Okay? So we'll keep moving here on the video. You guys have done a good job. Let me know if you have any questions. This is the first video I've done since we found out we are out of school until May 1st. So I'll try to keep you guys updated on here and on Canvas. So we'll do our best to get through this together. And main thing is that we keep on picking up some understanding as we go. So hopefully this modified practice is the best we can do, and we'll stick with it. All right, so number 3, 25x squared minus 4. All right, so hopefully number 2 had a lot of practice of just the process. Again, it's going to look like this. Now, this is going to work as long as these are all perfect squares. If any of these are not perfect squares, it doesn't work. Okay? And if it's a plus sign, it doesn't work. So what we're going to do, if there's a number out front, it's really the same thing as if it were x squared minus 4. It's just now we take the square root of 25. So that's 5 and 5. X squared turns into x and x. And then for 4, we're going to go plus 2 and minus 2. There you go. That's it. You don't have to do factor by grouping. You don't have to do all that stuff. This is, in fact, the fastest one that we have in this unit. All right? Okay, let's do number 4 on the same spot here. This time, we have a number out front, 81x squared minus 49y squared. Okay, so this time you not only have numbers for both like we did there, but you also have variables for both. Now, as long as it's an even exponent, we're okay here. As long as it's an even exponent, because our rule for exponents is that basically if you're trying to take the square root of an even exponent, you just take half of it, okay? Now here, like we've been doing, it just goes from 2 into 1. So let's go ahead and finish this one before we talk more about that. So 81 is a perfect square. The square root is 9. So 9 and 9, the square root of x squared is x. We need plus and minus or minus and plus. Again, it does not matter. So whatever you're most comfortable with, as long as you have one of each, that's what matters. And then the square root of 49 is 7. And now the y squared is a new thing, but we just tack it on at the end, just like we put the y up front. So there you go. It's 9x minus 7y, 9x plus 7y. As long as you have one of each sign, that's what works. Okay? Last one here. Hopefully this video will be a little shorter than the others, as there's not nearly as much work to show. Okay, now the last one, sometimes we have one like this on the assessment, which it sounds like we will have some sort of assessment later this week, so keep your eyes open for that. I'll let you know by email or on Canvas as soon as possible. We got a meeting coming up early this week with the math teachers, algebra teachers. We'll get that sorted out. Okay, it's not going to be... It'll be on Canvas. That's the only thing I know right now. Okay, and we'll figure that out. So, number 5, x to the 10th, y to the 8th, minus 1. Looks like this. Now, this is the first one we've had like this. As far as this goes, I was talking about this earlier. When you want to take the square root of an exponent, so x to the 10th is a perfect square. If it were x to the 9th, we wouldn't want to do this because... x to the 9th, we don't want to have a fraction or a decimal in the exponent. So the square root of x to the 10th, our rule is to take half because exponents have special properties. We got x to the 5th and x to the 5th. And so if there's two variables right here, just like we did with the numbers before, we had a number and a variable, now you do this one. So square root of y to the 8th is y to the 4th. So y to the 4th goes here. And then minus 1. Now sometimes students forget Oftentimes students forget here that 1 is a perfect square. The square root of 1 is 1. So it's going to be plus 1 and minus 1. And that's it. Okay, so there you go. There we've got factoring special cases. Look for the assignment on Canvas. And hope you guys are doing well and staying healthy and taking care of yourselves. So if you have questions, send me a message on Canvas and I will talk to you soon.